I have been exploring if and how several members of a team could contribute concurrently to the same model. I came up with a proof of concept which I call FredoConnect, and this video shows the main principle of FredoConnect in action. I am a member of the team called Mr. Blue. I have a blue background, and I want to share this model with the rest of the team. So I use create a shared project from this model. So normally I'm asked whether what is my author name, Mr. Blue, and also what is my shared drive where we put the shared elements. So this is already done, and you do it only once. So let's create the project. So the project code will be nice shapes. I can enter a display name which is different for the outside world, and even a description. So here I have created my project. Now another member of the team, Mr. Yellow, wants to work on the nice shapes project. So he gets fetch a shared model. So here is also asked normally but it's done only once for the FredoConnect shared drive on the network, and his author name as well, which is Yellow. So gets a shared model. So I have already several projects in FredoConnect. So let's pick up nice shape. I'm asked to give a name to the model locally on my local computer. So let's pick up yellow nice shape and save. And because I'm Mr. Yellow, I will put my background in yellow. So at this stage, Mr. Yellow has an access to the shared model, Mr. Blue as well, and both have a synchronized model. The model is very simple. You have a component with two subcomponents. Here it's a group, and here it's a component, both at the top level of the model. Now, FredoConnect has a small status panel, okay, with the update button, publish button, and here stop and hand is to detect the conflict and the activity. And here you have also the ownership of the objects by the team. Let's have Mr. Blue make some changes to the model. So it's going to paint the cube in blue, the house. As you can see here, he is now proposed to publish the changes. He made two changes. Let's see what happens in the yellow model. So far, blue has not published anything, but yellow is informed that Mr. Blue has modified two objects. Okay, so now let's go back to blue, and blue will publish those changes. So the changes have been now published. There's nothing more to publish for blue. And let's go to yellow. And yellow now has the update button showing that there have been changes by Mr. Blue. And if it updates, here is the update with the blue painting by Mr. Blue. So let's have Mr. Yellow make some changes. So it's going to paint the cylinder. He's going to move this, and is going to draw a door in the house. Okay, and maybe even paint here the cube. So he has now a number of changes to publish. So as you can see, Mr. Blue is informed of what is pending, and let's have Mr. Yellow publish and Mr. Blue update. Okay, so you see that now the two models are synchronized, and if you want to know the activity of the team on the model, you see that here you have the objects and saying who has modified what. So let's see about conflict detection. So let's say Mr. Blue wants to paint the cube in blue. Good. Mr. Yellow wants to paint the cube at the same time in yellow. You see that as soon as he has started to modify the cube, which has not been published but modified by Mr. Blue, okay, he is informed that there is a conflict. This small icon indicates that Mr. Blue has done something on the cube. So he better undo in order not to have any problem. Okay. So now Mr. Blue publishes and Mr. Yellow updates, and now we have the model synchronized again. In this proof of concept, I have considered that guides, that is guidelines or guide points, should not be considered as changes and be kept private for each team member. So let's add a guideline here to the cube, and even a guideline to the top model, to the subcomponent, and a guideline to the model. Okay, as you can see, there is nothing appearing in the status panel, that is, it is not considered as changes. Okay, let's even make a modification to the cube. So this is the modification. I publish it as Mr. Blue. Okay, I go to yellow. So I update it. You see that the cube has been updated, but the guidelines have not been transferred. So as a principle, guidelines are ignored, basically, whether you, even if you delete the guidelines, is not considered as a change. So guidelines are completely ignored. Likewise, row geometry at top level of the model is not considered as a change. So if I draw some line here at top level, if I put a label, This is not considered as a change, and of course, it's not published with the model to other members. Okay, so let's go to yellow. He updates, so he gets the the blue cylinder, but it doesn't get the row geometry. So basically, the top model can be used as a safe place to do some drawing or store some geometry. Okay, so again, at top model, what does matter is only groups and components. So in conclusion, the technical feasibility of sharing seamlessly a model is shown with this proof of concept. There are probably many details to work out. It depends on the team members to be on a shared drive or a fast replicated drive, and what is missing and of course could be added is a lock mechanism, that is an explicit management of conflict to avoid a mistake, and probably also because it makes sense to replicate a few other elements. It could be scenes, it could be style, and of course a way to annotate the model and share this annotation between members. This would be, let's say, more work for the user interface, but probably is feasible. So thank you very much for your attention.